This lesson is about acid-base titration curves. These are processes you've done a number of times. When you were in year 12, you've done acid-base titrations, but you've never really studied them in terms of what happens to the pH during the reaction. So we're going to consider what these kind of graphs look like. Let's have a look at the general features of the titration curve. So you've got two axes, and your x-axis will be volume of whichever reagent is being added, and your y-axis is pH. And you will see from this one, at your 0 point of addition, it is at 14. So you've got the starting pH, tells you which reagent's being added from the burette. So in this case, our starting pH is 14. So that means we must be starting with our alkali in the conical flask and our acid in the burette. Okay, and people are generally quite shocked when they first start to do this kind of experiment, in that essentially the pH doesn't change very much to start with. And this is actually a particular type of curve. This is for strong acid, strong base, but we'll look at some other versions as well. So it's always the case that you end up with a not very much of a change in pH, and then all of a sudden you get a really quick change. So over this long straight portion here, this is actually the end point of the titration. Now, an end point is the point at which you would get a sharp colour change in your indicator. And then if you read off there for the volume at that point, we actually call this the equivalence point. Which has the units of volume. So that's how much of, in this case, acid you have to add to do the neutralisation. So that's what we call the equivalence point. So equivalence point and end point are not the same. The end point is a range, can be a narrow range depending on what you're doing, but the end point is a range and it's a pH range. The equivalence point is a volume of a substance that needs to be added in order to do the neutralisation. And then you can see then that we just get, again, a kind of gradual smallish change in pH as it tends towards 0 when we're ending up with the acid in excess. So we have to consider titration curves for different combinations of acids and bases, for strong and for weak. Okay, so the shapes are characteristic on the combination. And you need to be able to examine each of those in order to be able to recognise them if you're given them in a question. So there's 4 different case studies. Make sure, just remind yourself, if you were asked to write an equation for these, that you remember what a strong acid is and what an example of a weak acid is as well. This is the same pH curve that we saw before. It's strong acid, strong base. Now this is, of course, started at the strong base, but you could do it the other way. So you could draw an equivalent curve going up this way, and draw it as if you were starting with the strong acid. It doesn't matter which direction it's drawn in. If it's in a practical context, then it will depend on what you're being told about the practical, so what's being added to what. So thinking about the features of this, the equivalence point on here you can read off, which is of course a volume, and you find that by finding this long straight portion, and this is the end point of the titration. And for strong acid, strong base, it has a large range of the end point. And if you take the middle of that, which is what we do, the kind of quoted pH at the end point, then you get a pH of 7. So you can quote the middle of the end point to give your pH at equivalence. And for this combination, it will be pH 7. So you're looking for this distinctive, very long vertical section in the titration curve, and that the middle of that long section is at pH 7 for the strong acid, strong base combination. This is the easiest one to spot. The other ones are a little bit more difficult for you to remember the details. The next combination we'll consider is if we have a strong acid and a weak base together. So something like ammonia here is a weak base. You'll notice I've drawn it the other way up. In this case, it doesn't actually really matter how we draw it. So here we are starting off with a strong acid and we're adding our base to it. The features of this curve you'll notice is the long straight portion is not as long, because you're not going to get to such a high pH because you're limited by the pH of the weak base itself. So you've got much shorter area for the end point, and the middle of the end point, the pH equals less than 7 at equivalence. And in this case, it will be around 5. So having the weak base in this combination means that the pH at equivalence is going to be less than 7. If you were to see this drawn the other way around, so you were adding the acid to the alkali, it's worth looking at this initially, because what you'd actually end up with is a very small fall at the start. So it would have the same shape and everything. It's just that if you add acid to a weak base, you essentially set up a buffer solution. So initially you've got this buffer solution which is going to resist pH change for a little while until it gets overcome. So just keep that in mind if you're ever asked to explain particular parts of a pH curve and it's drawn like that. Just think about what's happening, so why you're not getting such a sudden change as you add acid to the weak base. It's because you've set up a buffer solution which is resisting pH change. Now let's look at the combination of weak acid and strong base. So something like ethanoic acid and sodium hydroxide. You can see I've started here from the base, but again, it doesn't matter which way up it is. You're just going to examine what the pH is at the start and at the end to decide which way round it is, acid to alkali or alkali to acid. So we're going to examine the long straight portion to get the equivalence value in centimetres cubed, and then about halfway up the long straight portion is where we would consider the end point to be. And you'll notice here that it's above 7, okay? So end point is greater than 7 at the equivalence. So usually it's around 9 in the pH values, around pH 9. So in this combination, we end up with a pH equivalence as being higher than the 7 that we might expect. Okay, final combination, weak acid, weak base. If you look at this, it's a bit of a messy curve. So there is no clear end point. So there's no clear vertical section. So a titration curve isn't used to find equivalence. Basically, you'd never be asked to do anything like kind of calculation wise with these ones, because there's nothing that you can find. You can't find a middle point or anything like that. The only thing that you will be asked to do is you might be asked to recognise it from a picture like this. So you need to be able, the wobbly one that doesn't really work, that's the weak acid, weak base combination. So that would be something like ethanoic acid and ammonia. So let's summarise what we've looked at in terms of these titration curves. So you won't be asked to draw them in any kind of accurate way. You'll only have to recognise them if you're given them. You might have to plot them if it's a practical focus question, but you wouldn't be asked, but you'd be given the data then. You wouldn't be asked just to draw it from memory. If you are trying to recognise what it is, the first thing you need to do is to examine the start and the end of the points in terms of pH to see whether it's strong or weak and acid or base. And that will tell you what's being added to what. You look for the vertical portion of the curve to find the volume at equivalence. Halfway up there, you'll find pH. So it is a range, but you will have got a general pH at end point. So for strong acid, strong base, pH is equal to 7. If you have a strong acid and a weak base, the pH at equivalence will be equal to 5-ish. And if you have a weak acid and a strong base, then the pH will be equal to 9. Questions on this are generally pretty straightforward. We will move on following this to how this affects what indicator you choose for a titration, which is where it starts to get a little bit more difficult. So for now, just make sure that you can remember what the different combinations are in terms of their equivalence and the shape of these things as well.